Alright guys, so here is page 11 of Unit 6. This will be the last lesson for Unit 6. Then we'll look at the review, and then we're going to look at the, we'll have the test. Excuse me, hold on. Alright, so we have a new vocabulary word here. We're going to look at what is an asymptote. So, first of all, before we learn this asymptote, vertical and horizontal asymptotes, let's look at a parent graph of a rational function, okay? So the parent graph of a rational function looks like this. So you have f of x equals 1 over x, and it's this graph right here, okay? It's not a continuous graph. There is a break in this graph, but it still goes from left to right. And this is what it looks like, okay? So see how the graph is getting closer and closer to the x-axis but not touching it? That is because the x and y-axis are the asymptotes, meaning, so this graph is getting closer and closer over here, but it's never gonna go past the x-axis here. Like it's never gonna like go up like that, okay? And it basically flattens out. Same thing here, it's gonna come down. Down is going to keep going down, but it's never going to go down past the y-axis right here. It's never going to cross it, okay? It's just going to keep getting closer and closer to the y-axis as we go to infinity. Sorry, the x-axis, okay? So this line right here, this is an imaginary line. We don't see it, but we know it's there. We call this the horizontal asymptote. Okay, we call that the horizontal asymptote. And it's the same thing that happens here. This graph is going closer and closer here. It's never going to go through it, but this is your horizontal. So this line right here is the horizontal asymptote. Oh, sorry, vertical asymptote. Now, it does have, okay, so here's just a description about it, okay? So we have all of this. We don't have to like look through all of that. We'll just start with the findings here. Alright, so page 12. So identify the vertical and horizontal asymptote for each function. So a vertical asymptote, because it's a vertical line, vertical lines cross the x-axis, so like all the vertical lines always cross the x-axis. So for vertical asymptotes, it's always going to be x equals. And then for horizontal asymptotes, the one that goes sideways, they always cross the y-axis here. So we say that horizontal asymptotes are always going to be y equals. Okay. So here's our function. So it's a rational function because we have a numerator and denominator. And then we want to look for vertical and horizontal asymptote. Okay. Now on the previous page, it was showing you like how to do it algebraically without graphing. But today I'm just going to show you how do we do this by graphing. So I'm going to get my graph. I'm going to plug in my function. So you don't have to write f of x. You can just write your function right there. So you have division, x plus 1 over x minus 2. And there's your rational function. So we're going to look for the vertical asymptote, so like the one going up and down. So I like to just put x equals, and then you can just kind of guess. Well, I'm thinking it's x equals 2 right here, and you can just graph it, x equals 2, and see how it's right in between these two parts of the graph. And so that is my vertical asymptote, which is x equals 2. And then my horizontal asymptote right here will be y equals, and maybe I'm going to guess 1. Well, yeah, there, that looks good. You can scroll out and make sure it's not going closer. See how it's going closer and closer to it, but it's not actually touching it. Okay, so yeah, y equals 1. Okay. Let's try number 2. So you have here negative 2 over x plus 3. Okay, so let's do the vertical asymptote. So I'm going to do vertical asymptote is x equals, let's say negative 2. Oops. Negative 2, and that's not it, because see how it's cutting the graph? We want it to be more to the left. So do negative 3. Yeah, there we go. That looks good. So x equals negative 3 is my vertical asymptote, and my horizontal asymptote is y equals 0. Okay. Let me skip number 3. Let me show you number 4 here. This looks a little weird, but it's okay. Still work. So sometimes you could have more than one vertical asymptote. We usually just have like only one horizontal asymptote, but vertical asymptote you can have more than one. So for this one, you have 3 over x squared minus 4. Let's look at the weird graph. Okay, so right here, here's my first one, so that would be x equals negative 2. We'll look at it. Yep, and then the other one is x equals positive 2. And we can make it look nice. I can change it into a dotted line. Okay, so there are your asymptotes. Now my horizontal asymptote is, I believe it's just right here. I'm going to say y equals 0. It's that one right there, and you can check. You can see when you zoom in, it looks like it's touching it, but see there's a distance right there. And then the further and further you go into it, it's still not touching it. Okay, so y equals 0. And this is x equals negative 2, and then it has x equals positive 2. It has 2 vertical asymptotes. Let's look at number 5. So you have 3x plus 6, x squared minus 16. Okay, so let's do the vertical. So the vertical is x equals negative 4. Okay, and x equals positive 4. Okay, and then my horizontal, even though it looks like they're, so let me take this off, so those are fine. So x equals negative 4 and x equals positive 4. I'll just write it like that. Now the horizontal asymptote is towards infinity. So basically we're looking at the end behavior. Where'd my graph go? Okay. Okay, we're looking at the end behavior here. So like here, I would say that my horizontal asymptote is going to be at y equals 0. Okay, so it's right there, y equals 0. Even though it's cutting it right here, we don't really care about the middle part. We only care about the end behavior right there. Okay. Let's see if there's anything else. Let's look at number 6. So you have here boop, boop, x squared and you have x plus 1. Alright, so this is kind of weird. So it does not have, well, it has a vertical asymptote. So there's a vertical asymptote here, it's x equals -1. But there is no horizontal asymptote. Okay, so there's not a horizontal asymptote here. Alright, yeah, so that's about it. I think there's, oh yeah, let me go to the next page. There is one more thing I need to show you for this unit. So right here, you have here end behavior. So you will have end behavior questions here, where it's going to ask you what is the end behavior of this function. So let's actually look at all four of these things. So we're going to go ahead and graph it and see what it is. So you have here f of x equals 3 over x squared minus 2x minus 8. Okay, so let's look at the vertical asymptote. So there's a vertical asymptote here at x equals -2 and x equals +4. There's a horizontal asymptote at y equals 0. And then so for the domain, you're going to write all real numbers. So it's from -infinity and to +infinity. Except -2 and 4. X equals -2 and 4. Okay. Now the end behavior matches your horizontal asymptote. So end behavior is always equal to your horizontal asymptote. Okay. So your horizontal asymptote is 0, so you just write 0 and 0 here. Okay. Let me show you number 12. So here you have f of x equals 3x squared plus 4x over x squared minus 1. Okay, so there's a vertical asymptote at x equals -1 and x equals +1, I think. Yeah, +1 right there. And then the horizontal asymptote, let me just write this down first. Okay, a horizontal asymptote, let me take this off. So you have y equals, let me guess it at 2, no, higher, so 3, there you go, at 3. Okay, and then so the domain, you're just going to say all real numbers, so from -infinity to +infinity, except where you have your asymptotes, so -1 and 1. So if you were writing this in like set notation, you would say from -infinity until, or interval notation, -1, and then from, well, let's just leave it like this, it's too complicated. Okay, so, and then your end behavior always is equal to your horizontal asymptote, so you're going to write -3, sorry, not -3, +3 and then +3.